Hello all, welcome to part 18 of the Wireless LAN Security Mega Primer. In this video, we will learn about Corex Chop Chop attack. So let's go back to the drawing board and revisit our little diagram about how the web packet looks like. So basically inside the encrypted part, we have the encrypted data. Along with that, we have 4 bytes of the encrypted ICV. And if you remember, this is nothing but a XOR operation between the RC4 key stream and the plaintext data and plaintext ICV. So how does Corex Chop Chop attack work? Well, this also utilizes the whole message modification vulnerability. How? So imagine that this is the entire encrypted packet. Currently, the attacker has no idea about the key and hence he cannot decrypt this packet by himself. So what Corex Chop Chop attack does is that it takes this encrypted packet along with the ICV and first chops off the last byte of the packet, right, just before the ICV. So this is last byte of the actual data inside the web packet. Now what Corec does is he now has to go ahead and recalculate the ICV to create a valid packet. But the problem really is that he does not know the plain text value of the data which he had just deleted in the last byte, and hence he cannot calculate the value of the ICV reliably, right? So what actually happens is Corec goes ahead and deletes this last byte and creates a shorter packet. So this new packet is 1 byte shorter. Now, in order to adjust the ICV with the patch, just like we saw in the Cafe Latte attack, Corec does something very interesting. So he says, well, let me actually guess the value of this byte. Now, which can be 00 to FF, right? So he now takes the first value and says, well, my guess is that let this deleted byte have a plain text value of 00. And then he adjusts the ICV accordingly, right? And what he does is he now sends this packet to the access point destined to a multicast address. Now, if his guess was right that actually the plain text value was 00, then the new encrypted ICV which he adjusted would also be correct, right? In which case the access point would accept that packet, decrypt it, again encrypt it and send it out to the multicast address. So using the MAC address bytes of the multicast address and other interesting things, Corec can easily identify whether the packet which he sent out with the chopped byte was actually relayed or not. So what he does is he takes various guesses. So he says, well, let me try and first guess that the value of the plain text was 00 for this byte. In which case the new adjusted ICV would be ICV1, which would be here in the encrypted form. Then he sends it to the access point. So let's say the AP does not relay it, which means accepted is no. So then he goes on to his next guess and says, let me try with a value of 01. Again, it may be a no. Like this, he goes on till the time the access point finally does not accept the packet and relays it over the air. When this happens, the guess he had for the plain text value is the one which is actually the correct value of the plain text, and he is able to decrypt 1 byte of the packet, right? So at most he would require 256 guesses starting from 0 to all F's. Now what basically happens is, as one can imagine, he now moves on, and once he decrypts the last byte, he moves on to the last but 1 byte, and he follows the exact same process to decrypt that. Then he moves on to the next byte, right? And like this, he ends up decrypting the entire packet. And this is what the chop chop attack is all about. The only mathematics involved is how does he adjust the ICV by taking one of these as a possible guess, right? So the real math is out of scope, but it has to do with the way in which you can write all these polynomial equations pertaining to CRC and how it is possible to adjust the CRC when basically you chop off one of the bytes, which would be something like a prefix to one of the powers in the polynomial. Anyway, let's not worry too much about that. So moving on, what is the end result? We are able to decrypt the entire web packet byte by byte, right? And this can be orchestrated in two modes. One is an authenticated to AP mode, in which the attacker is actually going ahead and uh, impersonating either a client which is already authenticated, or he fakes an authentication, so that now when the access point receives his modified frame, then it will accept it because the client is associated, and then it will do the decryption, and if the packet is correct after decryption, that is the ICV etc is perfectly okay, then it would relay it. The other option is unauthenticated, in which case some very interesting behavior. If the web packet is valid after the correction, then if the MAC is not associated, then the access point, some access points actually send a deauth message. If the MAC is not associated and the packet is invalid, then no deauth is sent. So by figuring out whenever a deauth is sent compared to what was being sent in a previous packet, Corex tool can actually figure out whether the current byte guess was correct or not. And in Corec attack, basically he uses the MAC address, the source MAC address, as well as the destination MAC address to actually go ahead and encode those values inside. So for example, in the authenticated case, the multicast address to which it is addressed, the packet is addressed, contains that thing encoded. In the case of the unauthenticated AP, the source address of the client which he is using is something which would contain some indication or signature about which byte he is trying to decrypt, right? So now let's go on to an actual demonstration. So what we will do is, once again for Corec attack, we actually have air replay ng to our rescue, and it actually has an option called chop chop. So air replay ng hyphen hyphen chop chop, and post that all we need is basically the BSS ID or the ESS ID. In our case it is pawn me, along with the interface mon0, right? Now we have an actual access point running on that channel currently, pawn me, and now what I'm going to do is I'm going to go ahead and start a client. But before that, let me also run Wireshark so that we can start capturing some packets. So I'm basically just interested in the pawn me access point. So let me remove everything else. Also, I really do not need the beacon frames. Now let me go back here, and now let me start the client. So if you remember, in Corec attack, one of the first things was that we have to capture a specific packet, right? Now we've associated to the access point, and now the tool is automatically telling us that there is a packet of size 70 2DS, which means the client is sending it. This is the client MAC address, and it's asking whether we should go ahead and start decrypting it using the chop chop attack. So before that, let me actually add a little filter here. We already added it actually for the BSS ID, so I think this is good enough. Hopefully I have started the sniffing. Let me kind of verify that. I think I get that wrong practically in every video. So here goes, and we see a lot of data kind of going by. Let's go ahead and start the attack right now. So I say yes, and if you notice, the decryption process has already started for the various byte locations. Beautiful. And if you notice, it says the plain text packet has been saved in this file and the key stream has been saved in the other file. So let's actually look at what was that packet. Can start an instance of Wireshark here and give it the packet name, the file name, and this was actually an ARP packet being sent by the client to the access point. Awesome. So now you see the power of how you were able to decrypt a packet even without knowing the web key, and that is the power of the Corec attack. Now just to verify what really happened, we could go back to our Wireshark capture window, and you would actually notice that there's a lot of different packets kind of going through, the data packets which have been chopped, and a lot of other things which you can have a look at a later stage, right? So you would always see these little truncated packets which are kind of going from various different MAC addresses. So this is how it is really possible to actually decrypt a packet using the Corec chop attack. And I would really urge you to go ahead and try this out yourself. Well, that's all for this demonstration. You may kind of hear a little bit of tiredness in my voice because it's quite late here. Hopefully you enjoyed this video. In the next video, we will look at fragmentation based attacks which can be applied against web. So hope you enjoyed the video. Please leave your comment behind. Look forward to hearing from you. Thank you.